Okay, so what we're going to do today is the first day of, this was a summer assignment in years past, but we did not have a summer assignment for geometry, but I think it's going to be really helpful for us to review some algebra skills. So the first thing we're looking at here is our order of operations, okay? Maybe you've heard the acronym, please excuse my dear Aunt Sally, right? We look at parentheses first, then we notice we have parentheses here. We look for exponents after that. And then we have multiplication and division, which hold the same weight. We would just do those in order from left to right. And then the very last thing we do would be addition or subtraction. So when I see this expression here, 9 minus 3 times 2, I'm going to deal with the 9 minus 3 later. The first thing I have to do right now is multiply the 3 times 2. That's my order of operations. So 3 times 2 is 6. So this is going to be 9 minus 6. And then when I can simplify that, and that's going to be 3. So we look at our next expression, and I see that I have a 3 to the third power. So that exponent, I have to deal with that first. That's going to be my top priority. So we're going to hold off on multiplying the 2. So we have 2. I still have the multiplication symbol there. I'm going to do 3 to the third first, which means 3 times 3 times 3. That's what 3 to the third means. So 3 times 3 is 9, times 3 is 27. So this is really 2 times 27, and then finally minus 1. So what's our next order here will be to multiply, right? 2 times 27, that's 54. And then I can do minus 1 finally at the end, and my final answer here would be 53. Okay, again I have another order of operations here, but now I have a parenthesis, so I have to deal with what's inside the parentheses first. So 4, we're going to leave him alone. Inside the parentheses, I have 5 minus 4. That's pretty easy. That's 1. So what's going to happen here is we're going to have 1 squared. That's going to be the next thing that we'll do. And then we would finally multiply by 3. Well, 1 squared is 1. So we still have just 4 minus 1 times 3. Remember what we have to do first here. We have to multiply 1 times 3. So this is going to be 4 minus 3. 1 times 3 is 3. And that is equal to 1. Okay, I want you to take a second now and try number 4 on your own. And you can put your answer right in the next Edpuzzle question. Okay, so let's check and see how we did with this one. We have 16 minus 4 divided by 2. So the very first thing you should have done is divide the 4 by the 2. So we have 16 minus 2. 4 divided by 2 is 2. So if you did this correctly, you should have came up with 14 as your answer. Okay, what we're doing next now is still going to involve order of operations, but we're adding a layer to this where we have to put a variable in, a number value in for a variable. So I have 2 times x squared. That's my expression, but we want x to be 3. So this right away is going to become 2 times 3 squared. Okay? So now again we follow the order of operations. We're going to do 3 squared first. So that would become 9. So this is 2 times 9. And then 2 times 9 is just 18. We follow our order of operations. Okay, similarly in the next one, I'm going to have to deal with what's inside of parentheses first. So in there we're going to have 2 times 3. And then I'm going to want to square that. So I'll do the 2 times 3 first, which is 6. And now we still have that squared symbol there. So we do 6 squared, which is 36. And now we'll have 2 variables to insert here. So we're going to have 4. X squared is going to be 3 squared. So just put a little multiplication symbol there. So it's 4 times 3 squared. That's what I substituted for x. And then I also still have times y, which is 1 cubed. Well, 1 cubed is going to be easy. That's just 1. So I have 4 times 3 squared, which is 9, times 1. So all I really have to do here is 4 times 9, which is 36. Okay, so once again, this last one here, I want you to try that on your own and enter your answer in the Edpuzzle question when it comes up. Okay, so hopefully we did this one correctly. We got to watch the order here. They switched the x and the y on us. So this is going to be 2 times 1. Hopefully you didn't get tricked by that and put a 3 in there. Y is 1. And then we have minus 8 times 3. Looks like we'll probably get a negative number here. So 2 times 1, we'll do that first. That's 2. And now I have 8 times 3, which is 24. So now I have 2 minus 24. That's actually going to be negative 22. Okay, so here we have a series of one-step equations. So really, you're going to do one thing. You're going to either add or subtract, multiply or divide. Actually, number 11 has 2 steps to it. Okay, so here I have some number x that I'm trying to solve for, and when I subtract 5 from it, I get to 9. So if the operation that is being performed on the variable is subtraction, I need to undo that to solve for the variable. So I'm going to add 5 to both sides of that equation. So over here we have nothing left on this side except for x living by himself now. And that's going to be equal to 9 plus 5, which is 14. And here this time we have multiplication, right? We have 5 times x. So we have to undo multiplication by 5, and we do that by dividing. Notice here I added to reverse subtraction, we add. To reverse addition, we subtract. But to reverse multiplication, we divide. To the reverse division, we would multiply. So x is all by himself again now. 5 divided by 5, they cancel out. And now over here I have negative 10 divided by 5, which is negative 2. And I'm going to try to hang with you for these next two because I feel like they're a little bit tricky with the negative signs. It may have been a while since you saw some equations. So I'm going to do two things here. First, I want to get all the x's by themselves. So this minus 4x that's living over here with the 6, I want to send it over to this side by adding 4x to both sides. Okay? So notice what I did. I add 4x on this side, and now there's nothing left there except for 6. Over here we have negative x plus 4x. That's 3x. Now we divide both sides by 3, and we have x equals 2 for our solution. And the last one usually confuses people, but I'll try to explain this as simply as possible. We're multiplying by 3/4, so how do we undo that? We divide by 3/4. Okay? So I'm going to divide by 3/4 on both sides. Now I don't know if you remember, but when we divide by a fraction, okay, we have a rule in arithmetic for dividing by a fraction. It's equivalent to multiplying by the reciprocal. So that's going to be a much easier way to deal with this. So if I have negative 24 divided by, right, and that's going to, x is going to be all by itself now. These 3/4 will go away. So I just need to take negative 24 and I need to divide it by 3/4. Well, what I'm really going to do here, I'm going to take negative 24 and I'm going to multiply it by 4/3. Okay? So the quick way to do this is to get the smaller number first. Instead of taking 24 times 4 and then dividing by 3, I'm going to get a really big number. I'd rather get a smaller number first. So I'm going to take this 3, and 3 divides into negative 24 8 times. So now all I have to do is negative 8 times 4, and that would be negative 32. Okay, so a little bit of review here for integers. When the signs are the same, it's real easy. You just add the absolute values and keep that sign. So here I have negative 5 minus 3. It's really the same as negative 5 plus negative 3. So I have negative 5. I'm losing 5. I'm going to lose 3 more. This puts me at a total of negative 8. Okay? Here I have opposite signs. This is kind of the trickiest situation you might come across. Negative 9 plus 6. Well, I'm going to subtract because they have different signs. And when I subtract 9 and 6, I get 3. But I'm going to keep the sign of the larger numbers. And negative 9 is bigger absolute value than 6, so we're going to be in the negative when that is over with. Here again, another tricky one. We have negative 6 minus negative 2. What do we do with that? Well, I'm taking away a negative 2. It'd be like saying, well, you owe me $2, but I'm going to take that debt away. You don't owe me $2 anymore. So it'd be the same as somebody coming along and giving you $2 to pay that debt. So I would take negative 6, and really I'm going to add 2 to that. Right? If you lost $6 and then you lost another 2, but somebody came along and took that away, you in essence would only have lost $4 at that point. Right? They're going to take away that negative. So I have negative 6 plus 2 puts me at negative 4. Multiplication of integers, really simple. If they're the same sign, we just multiply them. 3 times 6 is 18. When they're both negatives, we're going to get a positive answer. A negative times a negative is a positive, so that's going to be positive 8. Likewise, a negative divided by a negative, positive 3. And here I have a positive divided by a negative, that's going to be negative 6. Okay? reducing fractions, I want to look to see if whatever the greatest common factor between both terms is, and I'm going to reduce it to that value. So 14 and 18, obviously they're both even numbers, so we know 2 will go into both of those evenly. I can't come up with anything bigger than 2. 4 does not go into either one of those. So if I take 14 and divide by 2, I get 7. If I take 18 divided by 2, I get 9. So that's going to be 7/9. Okay? 24 and 48, this really reduces down a lot. If you think about this, 24 divides into 48. So I can divide both numbers by 24. So look, we take 24, divide it by 4, it's 1. Take 48, divided by 24, and it's 2. That just reduces to 1/2. If you didn't see that, you would just keep reducing the numbers. I mean, maybe if you saw that 12 went into both of them, and you said, well, that's going to be 2/4, and then you'd see, well, this can reduce even further. That's going to be 1/2. Okay? Negative 45 over 100. The easy number to see here is 5. Right? If a number ends in a 0 or a 5, it's divisible by 5. So let's take negative 45, divide that by 5. We would have negative 9. And then let's take 100 divided by 5. That would be negative 9/20. Negative 36, divide by 6. Negative 6. Okay? Now we're going to add fractions together. So there's a couple things we can do here. I'm going to try to keep it as simple as possible. I'm going to show you how I like to do it. Of course, you could write them as improper fractions if you wanted, but the idea for adding fractions is you have to get a common denominator. So the first thing I'm going to do here for 13, I'm just going to take the 13 and the 2, and just bear with me. I'm just going to go ahead and add them together. Okay? I know I'm not done yet, but I got 15. Now I'm going to deal with the 1/5 and the 1/2. Well, how do I add 1/5 plus 1/2? I need a common denominator. So the common denominator is going to be the lowest common multiple of those two denominators, which would be 5 and 2. Generally, a really quick way to get to that would just be to multiply them. 5 times 2 is 10. Okay, so if I want a 10 over here in this denominator, this would be 2/10. Right? I multiply the top and the bottom by 2. Over here, I'm going to multiply the top and bottom by 5, and I have 5/10. So 5/10 is the same as 1/2. 2/10 is the same as 1/5. I add these two together, and if it's bigger than 1, then I'll add it to the 15, but I don't think I need to. I have 15, right, is my whole number part of this, and then I have 2 plus 5 is 7, so this would be 15 and 7/10. Okay, let's see how that works out with the next one. I have 3 plus 4, that's going to be 7, and now I need to deal with the 1/2 plus 1/3. Lowest common multiple or lowest common denominator now would be 6. You can see that. So this is 3/6 and this is 2/6. Right? So if I add those together, it doesn't go over 1, so this would be 7 and 5/6. If I had more than one whole, I'd add it to the 7 and be a little bit bigger. So now when I subtract the fractions, just so we don't get confused, I'll do a little bit differently here. I'm going to rewrite these as what we call improper fractions, where the numerator is bigger than the denominator. If you remember how we get to that, we take 3 times 10, which is 30, plus the 1 in the numerator. So this would be the same as 31/3 minus, now let's do the same thing here. 2 times 2 is 4, plus the 1 up here is 5/2. Okay? Now I need to do the same thing. I need a common denominator, which we just saw was 6. So how do I get to that? Well, over here I have to multiply the top and the bottom by 2. So this would be 62/6. Right? 3 times 2 is 6. So then we have to multiply 31 by 2 and get 62. 2 times 3 is 6. So 5 times 3 is 15. Okay? So I want to look at it that way. Now all I have to do is 62 minus 15. Okay, we subtract those, and that's 47/6, which is an acceptable answer. It's correct. It's in simplest form, but if you wanted to write it as a mixed number instead of an improper fraction, right, we know 6 goes into 36, 42 rather, 7 times. 7 times 6 is 42. So this would be 7. If we divide 47 by 6, we get 47 divided by 6 would be 7, with a remainder of 5. So this would be 7 and 5/6. It's almost 8, right? Because if it's 48/6, we would just have 8. So this should just be 7 and 5/6 if we did that correctly. So I'm going to pursue this one similarly. I'm going to take 6 times 7, which is 42, plus 1 is 43 over 6, minus 3 times 5 is 15, plus 1 is 16 over 3. So I don't have to do anything with the 43 over 6. My common denominator is going to be 6. But here, I need this denominator to be a 6. So if 3 times 2 is 6, then we would take 16 times 2 as well, and we would have 32 over 6. So I have 43 minus 32, that's 11 over 6. And again, if we like our mixed numbers, that's going to be 1 and 5/6. Now, the good thing is multiplication and division, I think, are easier with fractions than addition and subtraction, especially with the mixed numbers. All we do for multiplication is multiply across the top. 1 times 1 is 1. And we multiply across the bottom. 5 times 2 is 10. That's it. It's really that easy. Okay? With division, we have to add one extra wrinkle here. Remember, we have the negative 3/5. That's fine. I don't do anything with that. But I'm going to change this into a multiplication problem. And it's going to be a multiplication by the reciprocal. You just change that second number. Now, if we want to, we can just multiply across the top, 30, and 3 times 10 is 30, and 5 times 6 is also 30. It's easy enough to do that. We could reduce ahead of time if the numbers were really big. But here in this case, I get negative 30 over 30. That is just simply going to be negative 1. Okay? Okay, and our last part here, we're solving proportions. We're solving for an unknown variable. So what we do in this case, if I have 6 over n, if these are proportional, is equal to 4 over 2, then the rule for cross multiplication works. If I have this situation where I have a over b is equal to c over d, if they're telling me that that is true, then I know that it's also a true statement that a times d has to be equal to b times c. So I'm going to make b times c. I'm going to make use of that fact. So I'm going to cross multiply. 6 times 2 is 12. And then I'm going to cross multiply the other way. 4 times n is 4n. Everybody see that? 6 times 2 is 12. 4 times n is 4n. And now, like we had on a previous page, we just divide both sides by 4 to solve and find that n is equal to 3. And you'll see that that would be true. 6 divided by 3 is 2. 4 divided by 2 is also 2. Okay? Try this one on your own and let's see how we do. You're going to cross multiply. You're going to say 6 times 14 equals 12 times x, and then I want you to solve from there. So I multiply 6 times 14, that's 84. And then I have 12 times x. Okay, so I have 84 equals 12x. We're going to divide both sides by 12. So 84 divided by 12 is 7. So hopefully we got 7 for that. So now the next part here is just a yes or no question. Okay, so you're going to is the ratio a proportion? You want to see if they're proportional to each other. Okay, so this really should be an equal sign over here. It looks like a typo. Is 13 over 5 equal to 26 over 15? Okay, this one we'd have to know what b is in order to answer that question. So if the two sides are equal to each other, that's a proportion, right? We could solve this one with 2b equals 8 times 14, and that's 112. Okay, and then we divide by 2. So in this case, in order for those to be proportional, b would have to be equal to 56. 112 divided by 2 is 56. Now, is this proportional? So we answer the question, is 13 times 15, does that equal 5 times 26? Right? We're basically asking that question. If the ratio is a proportion, then cross multiplication has to be. So when I multiply 13 by 15, I get 195. And then when I multiply 5 times 26, I get 130. So the answer here is no, these are not proportional. Kind of came close. It's a little bit deceptive. But those are not equal. So like you can see here, 13 times 2 is 26, right? Well then, for these to be proportional, this should be 10 down here, not 15. 5 times 2 would be 10. So they are not proportional. So that's no. So write 5 equivalent ratios that are equal to 2 to 5. So what I'm going to do here is just start multiplying both numbers by the same number. So I'll show you what I mean. So I have 2 to 5. Let's multiply them both by 2. So that would be 4 to 10. Okay. Now multiplying both by 3, what do we get? 6 to 15. Multiplying both by 4, we would have 8 to 20. Okay. And then I'll write a fourth one, so we'll have a total of 5. Let's multiply them both by 5. What do we get? 10 to 25. Okay, and I guess if we want to get a fifth one here, multiplying, we did by 2, 3, 4, 5, multiplying both by 6, so we would have 12 to 30. So they stay in the same ratio there. You can see we went multiples of 5, right? 5, 10, 15, 20, 25, 30. Multiples of 2, 2, 4, 6, 8, 10, 12, and so on. Now, since 12 and 24 are not simplified, I can go in the other direction, right? Divide both of these by 12. Here's an equivalent fraction, 1 to 2. Okay, and now let's multiply up from there. That means we could do 2 to 4, right? I'm just multiplying both by 2. Multiplying both by 3, what do we get? 3 to 6. Multiplying both by 4, we got 4 to 8. And then multiplying both by 5, we got 5 to 10. So I want you to try this practice on your own. Obviously, you have the hard copy of this worksheet in Schoology, but you also see that your homework assignment, Day 1 practice, is in Schoology, and that's where you're going to enter your answers for these. Okay, so make sure you can use the hard copy to do your work if you want, but I want you to make sure you put your answers in the Schoology assignment.